Hello, and welcome to this film, which is the first of a few introductory films at the start of the IB chemistry course, designed to get you familiar with some fairly basic concepts that are absolutely crucial to grasp as you move through the course. Okay, so they're basics that we all have to have a good understanding of before we can study any of the topics, really. Okay, and this particular film deals with how we can decide whether a substance is ionic or covalent. It reminds us how, or tells us for the first time perhaps, how we name covalent molecules using a kind of prefix system of naming. And also it will cover some of the compounds, not all of them, but some of the compounds that don't use this usual naming system. So hopefully by the end of this film, you'll understand these things. First thing we're going to look at is what is a molecule. Now this is a really important term to use correctly because it comes up in lots of different topics, and misuse of this term can make it sound like you just don't know what you're talking about. So make sure that not only you understand that a molecule is any two or more atoms held together by covalent bonds, but that you remember it. Okay, and any time you use the word molecule or molecular or intermolecular or any of those things that have the word molecule in, you're remembering this definition. Okay, now a molecule could be an element, so my two or more atoms could be of the same kind, right? Or it could be a compound, in which case my two or more atoms would be of different kinds. But the key point about molecules is that they have to have covalent bonds in them. Now, when we're trying to spot whether a substance will have covalent bonds in it or not, we need to be familiar with the different regions of the periodic table. Now, this periodic table here has been color-coded. Okay, we've got the metals in yellow, the non-metals in green, which just notice includes hydrogen up here. Okay, and we've got things which are difficult to classify as metals or non-metals because they've got kind of properties of metals and properties of non-metals, and we call them the metalloids, and they're kind of on this borderline between the left and the right-hand side of the periodic table, or some people call this the stairway to boron. Okay, now if something is made of a metal and a non-metal, it's ionic. Okay, if something is made of only non-metals, then it's going to be covalent. Okay, and we'll understand more about what being covalent is when we study the bonding topic. But for now, make sure that any time you see two or more atoms joined together, and those atoms happen to all be non-metals, that you can immediately say to yourself, right, that must be a covalent substance. Now, it might be an element like O2, oxygen. Okay, it might be a compound like SO2, sulfur dioxide. It doesn't matter. As long as you've got two or more non-metal elements joined together, then you'll know that they'll be joined by covalent bonds. Okay, now, once we've decided if something's covalent or not, we can decide what its name is going to be, because when we name covalent substances, we always use this system of naming things using prefixes. And the prefixes tell us how many of a particular atom there are in the compound. These are the prefixes here, ranging from 1 up to 10. Okay, and they're important to remember, and for some reason people often get tetra wrong, I suppose because it doesn't sound anything like anything that you've dealt with to do with 4 perhaps. Okay, but the others are often quite sort of, they make sense to people. Okay, but make sure you can remember these 10 prefixes. Okay, now as I say, what these prefixes do is they tell us how many of each atom there is. Okay, so for example, if I'm dealing with sulfur trioxide, this tri is telling me that there is 3 of the oxygens. Okay, sulfur, the first element often doesn't have a prefix if there's just one of them. Okay, so by convention, if there's just one of an atom and we're naming it first, then often we don't bother with the mono. Okay, but this is telling us that there's one sulfur atom, 3 oxygens, so SO3. Okay. This one is telling us again that there's one carbon atom, it's first up, so we're not using the prefix mono. Okay, carbon tetrachloride, so I've got 4 chlorines. Okay, so my formula will be CCl4. Okay, now in this particular example, I've got two of my first elements, so I do have to use the prefix. It's only when we've got one of them we don't have to bother saying mono. Okay, dinitrogen, so two nitrogens, and tetroxide means there's four oxygens. So in this case, my formula would be N2, because I've got two nitrogens, O4. Okay, so by looking at the name of a covalent substance, I can decide what its formula will be. Okay, because the name will tell me the number of each atom that there is in it. And remember, by deciding that these atoms are both non-metals, then I know it's going to be covalent and that I have to use this system here. Okay. Now moving on, we'll just practice a couple of things where we get the name from a formula. So here we've got one carbon atom and two oxygens. So it could be monocarbon dioxide, but remember the first element we often don't bother putting the prefix. So this would just be carbon dioxide. Okay. This second example has only one oxygen in it, so instead of being carbon dioxide, it's carbon monoxide, and these are both, I suppose, fairly familiar substances, so you might be familiar with their names. Here's phosphorus, one phosphorus atom with 5 chlorines, so phosphorus, and then pentachloride, penta because there's 5 of them, chloride, not chlorine. Notice that the second element, the one that's joined to the first, always ends in "ide" here. Okay, here's something that we'd normally call water, I suppose, but we could give it its, its systematic name. It would be dihydrogen, because there's two hydrogens and one oxygen, so monoxide. Now, the realms we're kind of getting into here from this one down are molecules that we could name using this system of naming, but often we don't. If you look on your iron list, which you've been given at the start of this course, you'll have a list of all the ones you need to remember. But here's another one, which we could call dioxygen, but which people often just call oxygen. Okay, this one you could call trioxygen, but people just call it ozone. And you could call this one dihydrogen monosulfide. Never thought of how you'd name this before because it's got a common name, and tetraoxide, but we actually call this one sulfuric acid. So as well as knowing this system of naming, it's also very important to realise that there are some molecules which don't use this system, and it's important to be familiar with those because otherwise you won't know their names if you're given their formula, and you won't be able to decide what their formula is if you see their names. Okay, well, as we said at the start, these were the things that we were hoping to understand by the end of this film. One of the really important things with these films when you're starting out and as you carry on is to make sure that if you've got any questions, you don't just leave them for later. You come and ask me if you need some help with these things, or what's really, really good for other students as well is if you can post some comments on the YouTube channel, because that will enable other people to see not only your questions, but the answers that come up to them. Okay, so hopefully that all made sense, and the next film will deal with the naming of ionic compounds.